So as of right now, this room doesn't have any lecture capture. So like what you see up here on the screen is not going to be like recorded for you. So what I'm going to try to do and try to remember, and please remind me if you do not see me start the recording, is to record the lecture so I can post it on YouTube later for you guys to watch, so that you can still watch at your convenience. This also means that if I do some beautiful drawings and some beautiful artwork, which I'll probably have to do later on to explain how pointers work, it's not going to be captured because I can't draw on this. Or if I did, it would look really, really terrible in Microsoft Paint. Does that make sense? So come to class. If you're here, you're for ECS, here for ECS 36B. My name is Matthew Butner, and I will be your instructor. And today we'll go over a little bit about me, getting things set up, what you need to get downloaded, and then also covering the syllabus. So this is now my 10th or 11th year here at UC Davis. Started as an undergraduate in 2008. Came in as CS because I wanted to learn how to make video games. Spent 4 years learning CS. Never learned how to make video games. But that's probably okay. I still really enjoyed the problem-solving process and thinking things through and just getting something to work at the end of the day. And I hear, game developers don't have the best of jobs, or best of work environments, so maybe that was okay. After I graduated with my undergraduate degree from here at UC Davis, I had to decide whether I wanted to do master's or if I wanted to go to working. Working didn't sound like fun, and I wanted to see what teaching would be like, and to teach you have to have at least a master's. So decided to go and do a master's here at UC Davis. I didn't really have any particular focus. I was just hoping to go learn more about programming. But it turns out you pretty much learn everything you really need to know in your undergraduate degree, and your master's degree or your PhD is only if you want to be super duper focused on one particular thing. And so I wanted to learn a lot, so I just took the test option to complete it. But what I did find is that I really liked TAing. It was the most enjoyable part of the program for me, and it just happened that at the end of the, as I was finishing my graduate degree, there was an opening here for an instructor position. I applied for that, got hired, and I've been working here since 2014. I guess I also had an opportunity to work at Amazon as an internship over the summer. I did not like working there. Come talk to me in office hours if you want to learn more about why I didn't like working there. But it's pretty much they work too much. I learned a lot not to have to work a lot and get paid a lot of money for doing that. I get paid less here, but it's still a good amount. During free time, I like to play video games and watch YouTube and bake and cook. I used to do a lot of ballroom dancing in the past, but I did it too much and got burnt out. So I've been on hiatus for that for the past couple of years. Anything else you want to know about me before we move on and talk about more important things like this class? Okay. First, though, I have a question for you. What does it take to be good at something? Practice. Lots and lots and lots of practice. This is a key pivotal class for your career and learning how to program. And so there's going to be a lot of practice in this class. I would expect you to budget 20 to 40 hours per week for this class. Where you're at depends on how good your foundational skills coming in are. And it just varies really, really widely. For me as a student, when I was taking this previous version of this class, which was ECS 40, I was spending at least 20 hours every week working on the homework. So I'd get the assignment, I'd start working on the assignment the day I got it, and I'd finish it like the day it was due or the day it was before it was due. I was one of the top students in the class, so I don't know where you lie. Just budget a lot of time. I also only took 3 classes that quarter, and I recommend you only take 3 classes this quarter as well. It's still going to be really, really, really busy. This work here is so that you actually develop the skills and you're actually able to do something after this class goes. Besides, I saw a class once and I kind of remember what the structure looks like. I actually want you to be able to solve problems, be able to do things. I want you to be able to succeed in this class, your future classes that come up, and when you actually get a job too. I want you to be able to do stuff. So be prepared to put in a lot of time for this class and just budget accordingly. There are a few exceptional people that are somehow able to do this class, take 16 units and still do great in it. Props to you, but I don't think that's the average student. So heads up here on this. So prerequisites, you either need to have 36A or ECS 30. How many of you took 36A? How many took ECS 30? Okay, so mostly 36A people here. It's a little bit weird in the transition because, like, if you're coming from 30, I expect you to know C. If you're coming from 36A, I expect you to know Python. So, since most of you are 36A, well, so we're going to spend the first portion of this class learning how to do C, and then we'll transition over to C++. I'll post a lot of the examples and talk a lot of terms of Python, like this is how you did a for loop in Python. Here's how you do a for loop in C. Here's how you do an if statement in Python. Here's how you do an if statement in C. They look really, really similar, and we should be able to follow through a lot of the stuff really quickly. For transitioning to C, it's just that Python's very, very high level and has a lot of built-in things for you that make your life super duper easy. And C has nothing. If you want it, you got to build it yourself. It kind of follows a pay for what you use mentality. So if you're not using it, you don't have to pay for it. So if you want to use it, you got to include it or make it yourself, and then live with that. Once we get to C++, it'll be a little bit better, but it's still going to be worse than Python. Just FYI. Python makes it a lot easier to solve problems. Just as a general skill, I expect you to be able to solve problems in a logical manner without code. I expect you to be able to explain how to solve a problem step by step from beginning to end. I also expect you to be able to break problems down into smaller subproblems. Those subproblems being broken down into smaller subproblems, until you're finally able to get a small enough problem where you can solve it very easily, right? Don't write all your code in main, right? Use functions, right? Think about things through and how to solve them, and we'll get a lot of practice on that. The biggest challenge with this course is that your problems are just a lot bigger. Right? Most of the problems you probably had in 36A might have been like at most a couple hundred lines of code, or less than 100 lines of code. Depends what you're doing, right? Our final project that we're going to keep building on over the course of this class is probably going to end up over 1,000 or 2,000 lines of code. So just managing that complexity, all the moving parts, is what makes it challenging, and the fact that it keeps building and building and building. So what we did on homework this week, you need to reuse that for next week. So you need to use some good design principles. And the only way to get used to this is to actually, do it yourself. So we're here. You should know variables, functions, if statements, loops, recursion, all the basic things. And if you are missing the prereqs for this course and your petition hasn't been approved, you do need to see me in class this week. Otherwise, I'm going to kick you out, more or less. There are about 10 of you from when I last looked that are enrolled in this class but failed 36A. I'm not quite sure why you're still here, and I'm probably not going to approve your petition, but there was like 1 or 2 of you that I actually really need to talk to, because I'm not quite sure whether what you submitted was enough for me to say that you're in. So here's what we're hoping to learn in this class: object-oriented programming using C++. So we want to learn about classes, data encapsulation, inheritance, polymorphism, and templating. We're also going to learn how to use a version control system, Git. How many of you guys have used Git in the past? Great, maybe you can teach me something. We're also going to do unit testing via Google Test. Great, yeah, I just tried using it over the break. It was fun. We're going to use CMake to make our code a lot easier to compile for us, but it also makes it so that it's easier to just run it across different systems. Anybody use CMake before? Okay, 2. So we'll be using CMake in this class. We're also going to talk about how to solve problems in both C and modern C++. So we'll talk about how to use pointers, especially smart pointers, namespaces, iterative loops. Those are things that come from the more modern C++, the 2014, 2011 standard, not the 98 standard, which is what I learned. So use some of those new features. Here is our contact information. I'm still talking about the TAs about when their office hours are going to be set up, but mine are being held. I was there earlier today. 1 person showed up. I will be there on Wednesday. I will be there on Friday. I will be there right before class, those 2 hours before. Unfortunately, due to my schedule, I do not have any time to stay after class. So you cannot come and ask me questions after class. I'm just going to ignore you. So save yourself some time and just, come to office hours. So if you want to contact us, we'll be using Campuswire. You should have all received an invite last night, unless you joined the class this morning. Any questions related to the course should go there. Homework, trouble about installing software, exams, whatever. Pretty much everything should go there. only personal problems should be given to us via email, like my wife is pregnant, I'm giving birth, there's a cat on my ceiling, my house exploded. I don't know. Something that's only ever going to affect you and you only, that's stuff you can email me about. Make sure that you put ECS 36B in the subject so I know which class you're coming from. So Campuswire, I'll show you that in a second. If you weren't added, here's a link. The links to the class Google Drives are on Canvas, so you can go there to get over here. So if you weren't initially added to the class, go to the website, use that entry code to get in, and you have to use your UCD email to get in, otherwise it won't let you join. It looks like this. You can ask more questions, you can respond, you can earn extra credit by being interactive in this class, which we'll talk about in a little bit. But with using Campuswire, you have to make me this promise in terms of how you use it. First, you promise that you will Google your question before you look for it on Campuswire. There's a lot of useful information out there. Someone's probably asked your question before. You'll probably find it pretty quick at the top of your search results. It's also a skill you need to develop because you need to learn new things and new programs and new functions, new whatever. Google has the answers, so Google first. If you fail in finding your answer Googling, then see if somebody's already posted the question here in Campuswire. You have this little search bar over here. Search a little bit to see if somebody's already asked it. If they have, it might have been already answered. And once it's answered, great, you already have your answer, saved you some time. Save everybody else from having some duplicates. Finally, if you fail to find your answer and you've already searched for it, then do post. I tend to look at Campuswire pretty frequently, but it might take a day or so to get a reply. You guys can also reply, right, and give answers, which is great because it cuts down on the response time. And if I like your answer, I'll give you a little vote, and that'll learn you a little bit closer to getting extra credit, which we'll talk about a little bit later. Any questions on Campuswire? Okay. So here's all the things that we're going to need to get: a Codathon account, a Gradescope account, which you don't really need to worry about, Campuswire, Pull Everywhere accounts. Just when you're signing up for these things online, make sure you use your UCD email and you use your name as it appears on UC Davis so that we're able to figure out who the heck you are across these different applications, primarily so you can get a grade at the end of the day. Because if you enter superhotguy at hotmail.com, I have no idea who that is. I have no idea how to associate that grade to you on Codathon with your grade over on Canvas. So that's the one that matters. So sign up with everything on UCD. Make sense? So some other things we're going to be using, again, Git, CMake, Google Test. We'll talk about how to install these things later on. But here are tutorials for all of them. I wasn't able to find a good book for C or C++, unfortunately, given your course level. So you have Google, Google C tutorial, C++ tutorial. We'll also have everything we're going to cover in class. Hopefully, I'll be able to find something that's at an appropriate level for you. So Codathon account, go to codathon.com/courses. This is where you're going to be submitting your homework to get graded. Just search ECS 36B in the search bar, and it should pop up with the rest. It should probably be the only one that's there. Sometimes people accidentally have a habit. So you would search over here. You'd be like ECS 36. And for me, it won't show up because I'm already in. But, it looks like someone... oops, go back. It looks like someone, created their own ECS 36B. Right? And people have a habit of doing this for whatever reason. You don't want to click this create button because you're not running your own course. So, search in the search results for the one that's ours and then go join that one. And if you are the person that's in your own lonely class, make sure you kind of ignore that and go back to everybody else. You can also do your coding on Codathon if you like, but I'll also show you another IDE, which is C-Line, which has more features for you. But it is nice if you're working online with somebody else because it kind of has like a Google Doc functionality, whereas you're both coding, you see what the other person's doing, which can be nice. So make sure you get signed up for that. Grade scope, this is if we do written exams in this course. I'll sign you up for this later on. Just make sure you accept the invite. Happen a little bit before the first midterm. So we're also using Poll Everywhere, which is in case you do not feel comfortable asking questions in class and you want to be able to get them to me. You can go through Poll Everywhere and you can submit a question. We have our over here, Saja. She'll be monitoring the polls, and as she gets those questions, she'll ask them to me. Your responses to that poll are completely anonymous. We have no idea who's asking them, and so if you do not feel comfortable raising your hand and asking a question in class, this is the way to go about doing it. Some other things, we have Canvas, and then we also have the Google Drive. The links for the Google Drive accounts are on Canvas as well. There's also a link to the ECS 30 Google Drive, which was C. So if you have more questions and you want more slides and more examples and more information on C topics, go there. So grading, this is what our grades look like. Most of your grades is homework, so do that homework. It's important. Learn a lot doing that. We'll also have Canvas quizzes a couple of times, probably not too often. We'll have 2 midterms and we'll have 1 final. You also have the opportunity for extra credit if you participate on Campuswire. So if you level up to level 2 on Campuswire, I'll give you 1% extra credit in the class. And if you get to level 3, I'll give you another 1%. So a total of 2% extra credit overall in the class. So be helpful, be active, respond to people's questions, right? It's a good thing to do. Any questions before I keep plowing through this stuff? Yeah, in the back. Yeah, all the slides, all the class material, it's in the course Google Drive, which, again, you should have a link on Canvas to it under announcements. So go there, you'll find everything that we're doing in class. The only things that don't show up in the Google Drive are solutions to problems. You'll find those on Canvas. Anything else? Okay, homework, you generally have like a week or 2 to do each homework. Sometimes we have larger assignments and you get up to 3 weeks. Wow, don't waste the time. You need it. You'll be pressed to actually finish on time for every single assignment, except maybe the first. It's pretty easy. Again, timing can take a huge amount of time depending on who you are as students. I'm pretty sure I had students like spend 80 hours on the class. Never my intent to get that high, but they were spending that much time. Budget a lot of time for this class. On each assignment, I'll try to put the time that I took, if I remember to record that, to give you an estimate of how long it's going to take you. It's not going to be like 1-to-1. You're going to have some multiplier. I take 2 times, 3 times, 4 times, 5 times as long as Matthew, whatever it was. When I was taking this class, I was like, 20 times or 10 times slower than the instructor. So, gives you a rough idea. I have no idea where you're at, but I'll try to put that up there to help you out. So you submit on Codathon. You'll generally have 10 to 15 assignments, submissions per assignment. This is just to, encourage you to test on your own. It's something you need to get practice with. So do, test your own code before you try submitting. You can work up to groups of 2. If you and your partner are working together, you submit once as a team. If you go back to Codathon over here, you should see that there is a issue loading it. Well, okay, there we go. See, there's this Teams tab. You go to the Teams tab. If you, talk to somebody, you create a team, and then you'd invite them to the team. Not sure why it's so slow right now, but apparently it is. So go there if you want to create a team, and your team would submit once. So it finally popped up. So, create a team, add your team member to it. Your submissions are like shared jointly across. So, if you submit as your partner 5 times and you get a total of 15 submissions, there's 10 left, right? So 15 per group or 10 per group, right? If you're in a group, you don't get double the number of submissions, so just be cautious of that. The other thing that I want to briefly mention is finding a good partner. Well, 1, you do not have to work with the same partner in every single assignment. If you work with somebody on the first homework and you're like, man, they blow, right? go work with somebody else. These aren't marriages. You can get divorced at any time. I guess just like with a marriage, but you don't have to stay together, right? If they're not working out, go join another group or work by yourself. If you want to be working in a group, these are my recommendations. Find someone at the same skill level as you. It's not very helpful if the person's a lot better than you, because you're going to get left in the dust and they're going to do all the work. It's not helpful being a partner with somebody that's a lot worse than you, because then you do all the work and they do nothing. Or they do some work and, then you have to go fix their work because it doesn't work, right? You want someone that's, pretty close to where you're at, but just thinks a little bit different than you do. You're also going to want to consistently meet up to be doing the work. It's not really helpful if you're like, I'll do part A, you do part B, you do problem number 3. Different topics are covered in different parts of the problems, and so you're going to be missing out if you try to split the problems up like that way. You're really going to want to do pair programming, sit down right next to each other, be programming at the same time. So if your schedules don't mesh and you're not really able to get together, it's probably not beneficial to be in a group. The main benefit of being in a group is being able to bounce ideas off each other. Say like, well, what about this? How do you think this would work? What about this idea? That's the major benefit. Also having someone that thinks about things a little bit differently than you and sees the world a little bit differently than you is really, really helpful, right? You don't want 2 clones. It's not very helpful then. A little bit different, but about the same level. Does that make sense? Also, if you want to spend a lot less time working on your homework, come to office hours. Literally 5 minutes or 10 minutes in office hours can save you hours worth of work. So come. They're there. They're 6 hours a week from just myself, and the TAs have about 3 hours apiece as well. So that's they have a total of 9 among them. So you have 15 hours of getting help. There's also the CS Club, which also offers tutoring, so you can go there for assistance. But yeah, make use of office hours. They will save you a lot of time. And I've had students that that learned a lot in them, and basically were only able to complete the class because they came to them. Right? If they just tried to do things by themselves, they totally would have failed. So come to office hours, really, really useful. It's pretty much possible to get 100% on all homework assignments, because you'll be getting your grade back from Codathon about how well you're doing. So if I'm not happy with getting 60% of the test cases passed, which means you get 60% of your overall grade, keep working on it. Figure out what's wrong. Fix those problems. Your life will get better. But it does take time. You can also submit homework up to 1 day late. Your grade will decay logarithmically after the due date. The reason for only 1 day of leniency is because you probably need to start the next assignment right away, and I cannot release my solution to you until afterwards. So if we're on the point of the projects where we're building things up and up and up and up, if you struggled on this homework and you need to use it for the next homework, you can use mine instead as a starting point. Perfectly okay. Any questions? Okay, we'll also have a couple of quizzes. And we'll get them up. They'll be online. They'll be on Canvas. They should be pretty easy to fill out. There'll be a combination of multiple choice, fill in the blank. One thing to be really careful about is some of them that ask you to fill in the blank are very white space specific. So if the answer is 3 space plus space 4, you gotta enter 3 space plus space 4. 3 plus 4 doesn't work. So watch out for that. I'll be on those problems that have white space in their answer, I will be very specific about where you put white space and where you do not put white space. So pay attention to the problem when you're there so that you don't accidentally get points marked off. So 2 midterms. I'm not sure if they're going to be a project, an online exam, or an in-class exam. These are the dates that we're planning on having them. First one would be about C topics, so just pretty much C and C only. Second one would be about basic classes, maybe some inheritance in there as well. And then the final would cover the remaining topics as well. If the exam is in class and it's written, you're going to bring an 8.5 by 11 page of handwritten notes to the exam. You can write whatever you want on them, front and back, it just has to be handwritten. So final, it's either going to be written or a take-home project. I'll pick later on what I'm going to be doing. If it is written, it's going to be in this classroom at this time unless we get moved classes. Not this time right now, but at 8 a.m. because that sucks. That's really early. If it's written, you're gonna bring 2 pages, front and back, 8.5 by 11, whatever you want to put on it. On days that we have exams, if they're in class, we won't have discussion later on that day or any office hours if they fall after that class period. So for example, if we had a exam today, there wouldn't be any discussion right after this class because we'd be grading instead. But only if it's, written exam. If it's not a written exam, we'll have discussion like normal. And then again, if they're before the exam on that day, of course, we're going to hold them. So regrades, you don't get regrades on your homework. You know what grade you get when you submit. You're happy with that? I'm assuming, you're happy with it. If you weren't happy with it, you would have kept working on it. If we have written exams, you can request a regrade on Gradescope, or if you think we've made a mistake or on one of the quizzes, you can come into office hours and we'll take a look at the problem. So cheating, I should say just don't do it, and that should be enough, but some of you still will. It's really easy to catch you because we have plagiarism detectors, and it's really easy to see if you have somebody else's code. So it's another reason not to. Please also read the UCD Code of Academic Conduct. You didn't know it's possible to plagiarize from yourself? I never knew that. That's weird. I know, I agree. I don't know why, but you can, so you just watch out for that. Not like that's something I would ever go after you for. But cheating is really anything that gives you an unfair advantage over somebody else in this class. You don't want to cheat because you actually want to learn. You want to learn so that you can actually be able to do it in the future. You want to be able to do it in the future so you can get a job. So cheating really just hurts you. This class is not curved because I don't think you should be competing against each other. You should be competing against the standard. You should be, X good enough to be able to do well in the class. So no curves. So you really only hurt yourself when you're cheating. So some examples of cheating include, but aren't limited to, plagiarizing or copying code, searching for solutions online for a particular problem. If you're looking for ideas on how to solve a problem, like how do I figure out if a number is prime or not, that's fine. If you're looking for code that figures out if a number is prime or not, that's wrong, right? Ideas are fine. It's concepts that would be incorrect. Ideas are fine. It would be implementations that would be wrong to search for. Yeah. So for Stack Overflow, it's okay to say my code is not compiling because I have this error. How do I fix that, right? Or if you're looking for doing generic things, that's fine, right? But if your problem is, I need to figure out if these 2 words are anagrams, can you please give me some code that figures out if these 2 words are anagrams? Not okay, right? Don't look for answers for the particular problem you're solving. If you're looking for how do I use a vector, or how do I use strings, or how does templating work? All perfectly cool, okay, because they're concepts and ideas. They're not a particular implementation detail. Does that make sense? Don't look for old exams or past homeworks. Don't give assistance or code, or don't give code to somebody outside your group. Again, you're welcome to discuss ideas, but as soon as you start looking at somebody else's code, or you start talking about code, you're probably going way too far. Doing work with somebody that you're supposed to do individually. And if we have an in-class exam, you're not allowed to sit next to somebody because, gets rid of cheating arguments, because if you happen to both be studying together and you both studied incorrectly together and you both put some weird wrong answer and you both sit next to each other, to me it looks like you copied off each other. One of you copied off the other person. But if you and your friend studied together and you both did some weird study thing and you're sitting over there and your friend's sitting over there, I don't think you copied off each other because you're not sitting next to each other in the class. So if you get sent to SJA for cheating and your answer is, we studied together, you get a 0. Right? Also, if you're found cheating, I can give you up to a 0 in the entire class now, not just the assignment. So don't cheat because you are risking a lot. The other thing is on on Campuswire, don't post code whether it works or not, because somebody can copy that code. And if they do copy that code and there's only a minor error and they fix it, and they put it in your code and you get your code working, you put it back into your answer, well, again, looks like you plagiarized or someone plagiarized with the other person. That's there to protect you. So no code really should be going on Campuswire related to homework. But again, if you're like, how do I use a vector? How do I use a string? How do I write a function with optional arguments? That's all okay. For discussions, you have to go to your discussion. We actually don't have enough time to get through everything we need to in class. So discussions are more lectures on other topics. So make sure to come. I'll be leading them if we're actually covering a topic that day. So that's why I'm busy right after this class. And you have to go to your own discussion because there's not enough room, right? You can see it's super full already. So you got to go to your own. If you do have a friend that's in like some other discussion and you want to go to their discussion, they want to go to yours, that's fine if you swap. I just don't want too many people heading all to one discussion because it's at a great time or something. Do you guys have any questions about this class before we get started in our last 9 minutes to talk about C? Yeah. So again, I mentioned at the beginning, we're attempting to expand the course right now. We don't know how much bigger it's going to be able to get. A lot of it would involve us getting another room instead of this one. And maybe some other rooms for discussion sections to be able to allow more people to fit. So I don't know. It depends on where you're at. Last time I taught this course, I think like a third of the people dropped. But we also started out a lot tougher too because I had you like implement a C version of Monopoly for your first homework assignment. And people were like, nope, I'm not that good with pointers, out of here. And so you guys don't know C, so I can't start you off that hard. Otherwise I would. So I don't know. Yeah. The question is, if you're given a problem that's being asked to solve in C, are you allowed to use C++? No. If I say C, I mean C, and you're stuck with C. Really, one of the main versions, main reason we're starting with C at the beginning is so that you get comfortable with pointers. Because pointers are the absolute bane of everybody when they took ECS 30 and we covered C. And we spent like 2 weeks talking about that, right? We have 2 weeks for all of C here in this class. So we'll spend most of our time talking about pointers, but I actually want you to get practice using pointers and get comfortable with them because C++ still uses a lot of pointers. It's just they're behind the scenes, and you need to know that they're there and how they work before you know. Go. You can obviously use it without knowing how it's actually working, but it's better if you do know how it's working so you can figure out like what the weird behavior is if you get some weird behavior sometimes. Yeah?
Is there any other way to test our code, like meeting?
So the question is there any way of testing your code besides submitting your code onto the website? You are a person. You should figure out, like, you know, if I'm trying to like add two matrices together, you can do a small matrix by hand, right? What's the answer? Plug that matrix into your program. Does it match? If it's yes, you know it's working, right? You can test your own program. And you should be testing your own program. It shouldn't be left up to me. Because when you get to real life, you got to test your own code. Make sure it's working. Anything else? Okay, great. We have 5 minutes. Let's talk about Hello World. Hello World. So in case you didn't know, there is some like setup videos about how to get everything installed and set up. If you go to our course Google Drive, they're all here in this folder getting set up. There's links to videos also that kind of like show me doing it. I don't have Linux and I don't have a Mac, so it's all about a lot of Googling to see what that's supposed to look like. But it should go pretty smoothly if you follow along with those videos. So again, just read the slides. This is C-Line. This is our IDE. How many of you have used an IDE in the past? How many of you still prefer just use a basic text editor? It's personal preference. You know, I like a lot of the features that the IDE offers. So I use it. But there is the downside that the IDE can be kind of heavy. As you'll see, like getting this loaded the first time takes quite a while for everything to get set up. The other question is, can you read this, or do I need to make it bigger? Bigger? Okay, bigger. So, big enough or bigger? Bigger? Okay. Bigger? You know, probably, if you're still asking for bigger at this point, you probably need to go get your eyes checked and get a new prescription. Hey, I wear glasses, it's fine. Okay, so first is, here's what hello world looks like in Python. You know, it just says print hello world, great, you're done, right? As you can see, your comments start with pound signs, and your print is the print statement. So here, in C, you can do multi-line comments. Multi-line comments start with a /* and end with a //. Everything between them will be treated as a comment. The stars in between are just nice, decorative, and they're pretty. And the IDE put them in there for me. You don't need them to get it to work. So C, again, has this mentality, and C++ as well. You should only pay for what you use for it. If you're not using a feature, you shouldn't be penalized for it, right? You shouldn't have to pay any memory penalties or any performance penalties for it. So there's not much built into C. You get basic arithmetic and some functions, and that's about it. So for other things that we need to use, we need to include them and include the libraries that do a lot of the common functionality, like printing to the screen, writing to files, writing to the screen, getting input, doing output. So to include a library, it's #include std or name of the library inside the triangular brackets if you're including a system library. We'll talk about user-defined libraries in a little bit. So stdio stands for standard input and output. So if you're ever doing anything that involves getting input from the user or putting stuff out to the screen, you're going to be using this library. It's also used for reading and writing from and writing to files. So you'll see this one a lot here in C. Also, I should mention that #include, what it means copy and paste. So don't forget that. When I'm including stdio.h, it really says take the contents of that file and paste them here where I'm saying paste them here. Also, these lines that start with the #sign, they are preprocessor directives, which means they're telling the C preprocessor to do something, and they're not really C code. They're telling the preprocessor to do something with this code to transform it. And then that transformed, again, the copy and pasted in this case code will then be what's actually compiled later on. So now that we finally got down to it, here's our function, hello world. So in C, unlike in Python where your code kind of starts at the top, in C, your program always begins at main. And there can only ever be one main. It's like Highlander, right? There can only be one. Right? You guys never see that movie? Okay. So we always start at main. This value on the front of the function declaration of main is int, which means main will give back an integer, which you're going to see down here in the return 0. This value that main returns is a success code. So if main returns 0, it means everything completed good. If main returns something that's not 0, it means something went wrong in the program. And whatever that number is that you get back is application specific. It can mean different things in different applications, and generally you look up that applications manual and tell you what that user code meant. And a lot of times, also when it fails with some code, it will also print something out to the error console to let you know a little bit more details about it. So printf, that's the function that we use to print stuff to the screen. And then here you can see we have string literals. They're placed inside double quotes. In C, you have to use double quotes for strings. You can't use single quotes, right? Python, you can interchange them, single quotes or double quotes. Strings, which are more than one character, always double quotes. I'm also assuming you've seen the /n character before. Has anybody not seen /n? It means new line, in case you didn't know. And then two other quick things is all of your statements in C have to end with semicolons. Don't forget the semicolons. You'll forget the semicolons, but it's pretty easy to fix. First program I ever wrote, write a semicolon in every single line. The other thing is that indentation means nothing and white space means nothing in C, unlike in Python where the indentation denotes what code block you belong to. So here, even though this code is indented, it means absolutely nothing. It's just to make it look nice. And you still indent your code to make it look nice. Code blocks here in Python or in C are defined by curly brackets. So everything inside these two curly brackets are what actually belongs to main, regardless of the white space inside. And then finally, I'll let you go. The double slashes right here are for single line comments. They're the equivalent of Python's #sign. If you're here in C line and you want to actually run your code, you press the play button. Talk more about compiling later. But there, hello world. See you guys in class later on.
on Wednesday, or if you have discussion right now.